Hello everyone. So now let's try to see whether we can reduce this particular time complexity for sorting array problem. So it is currently O of n square because we are using 2 for loop. So let's take the example. So 1 2 3 4 and 5. So till now what we were doing, we were taking 1 and we are comparing with 2 3 4 5. Then we were taking 2 and we were taking in the first iteration we are taking 1, then in the second iteration we are taking 2 3 4 5, and we are comparing it with the next 3 4 5, right? And then 3 4 5, then we are taking 3 and comparing with 4 5, something like this, right? So is it really necessary to compare one with all these following numbers? Is it really necessary to compare with all the necessary following numbers? No, right? Because let's say we are given one array 1 2 3 4 5, right? So if we compare 1 with 2, 2 with 3, 3 with 4, and 4 with 5, whether let's say it is I, right? I is 0 1 2 3 4, right? So if I say a of 0 is less than equal to a of 1, right? So this should be true. Same way a of 1 is less than equal to a of 2, right? This should be true for these two numbers. Then similar way we have to compare only one number with the following number. So ith number with I plus 1 number, right? We don't have to compare with all the numbers. So can we do that? Yes, we can do that. So for I equal to 0, I is less than n minus 1. I'll tell you why n minus 1. I plus plus, and inside that what we'll do, we will do if a of I is greater than a of I plus 1. A of I is greater than a of I plus 1. Then what we'll do, we will return false, right? Or else I plus plus, and same way we'll continue. So I'll become 0, then we'll compare this. When I'll become 1, we'll compare this, right? Same way we'll go on, and then return true, right? So why n minus 1 and not n? Okay, so what we are doing, every time I is 0, right, we are comparing with I plus 1 inside the loop. Whenever something like this happens, we have to reduce n by 1. Why? Because in this case, let's take the example 2 3 4 and 5. Here n equal to 5, right? N equal to 5. When my in the first iteration, we'll go iteration by iteration. In the first iteration, what we'll compare 1 with 2, right? This time I'll be 0, right? I'll be 0, and I plus 1 equal to 1, right? Then we'll compare this. Then I become 1, I plus 1 become 2, right? 0 1 2, right? Then we'll compare this. Then I will become 2, I plus 1 become 3, right? This is 3 and 4, right? Then we'll compare this. I will become 3 and I plus 1 become 4, right? Till now we have compared till how much time? We have compared till I equal to 3, right? I equal to 3, right? So n minus 1 is 3, and n minus 1 is 4, actually, sorry, n minus 1 is 4, right? So basically I will become 3 in this condition, and my I plus 1 is 4, right? So my n minus 1 is 4, right? And my I is already 3. Till now it is correct. Then if I say, if my I becomes 4, right? I plus 1 becomes 5, right? And if it is n, in this condition it will go inside loop, but I plus 1 of 5, that means array of 5, it doesn't exist, right? So we don't have to compare the last element with any other element, so that's why we are running till I is less than n minus 1. And in this condition the time complexity will be O of n, only one single for loop, and space is O of 1 because there is no extra space we are using. So let's try to write the code for this. So I'll just remove this, and what we'll do, for int I equal to 0, I is less than n minus 1, I plus plus, so that if a of I is greater than a of I plus 1, then return false, done false, right? Or else return true. Run this. Sorry, it is array, so a will not work. Array of I plus 1. So yes, it's accepted. So yeah, we have passed our problem. Thank you for watching.